Okay, there we go.
You're good.
Okay. So the first function that we have is one of the radical functions. And what we're going to do, so you know how the parent function looked kind of like, this is not exactly accurate, but it kind of looked like something like this. So what we're going to do is that we're going to apply the transformation to that. So first, we're going to move it within the radical. So the original parent function will look something like this. Okay, that's how it would be y. So y equals square root of x, okay? Something like that. So, but now we have a negative in front of it. So that means, what would it mean? Like when we had a negative in an equation, what would it do to the graph?
You would like flip it over the x-axis. It's reflected.
Good, it's reflected.
Reflected.
So basically that's what's gonna happen, that's one of the first steps that's gonna happen in this. But also what happens is that you move it to the right 6, because you know how in the original equation it looks like this, but we now have a minus 6, and how it goes, you know the original transformations? I'll probably do an example. So let's just say we have y equals x squared.
Yeah.
If we did y equals x squared minus 6, I think that's right, you would move it to the right 6, and because it goes opposite sign. So we know that this is to the right 6, it starts from here, this is the anchor point. We know it's gonna move to the right 6 times, and also it's also gonna be flipped. And do you remember when you have something that's like outside of like where the x is, what would it do?
It moves up or down depending on what it is.
So what would this be? It would be moving it up
Go
3.
up 3.
Okay, so we're gonna take the anchor point, and we're gonna start from the anchor point, which is 0, 0. So now that we're gonna start at the anchor point, we can move this what? We can move this to the right 6. 1, 2, 3, 4, 5, 6. We can move it up 3. 1, 2, 3. So this is our new anchor point. I'll probably change it later because we have a restriction that will change how the circle looks. So now what we're going to do is that we're going to do a t-chart. So, and y is equal to 6 plus 3. So let's just say we plug in
1.
1. Okay. No, let's not plug in 1. That
No.
comes up to an ugly number.
Okay.
Let's do 10. So if x is 10, that means 10 minus 6, that would be 4. So that would be negative 4. So negative 4 plus 3 would be negative 1. You understand how I got there?
Yeah.
Okay,
But
so
isn't
we're
it
gonna
the
do
square root of 4?
Yeah.
Square root of 4?
Yeah, square root of 4 is 2, so it'd be negative 2 plus 3.
Ooh. So if we have 10, 10 minus 6 would be 4.
Yeah. Square root of that is
Square
2,
root is
and then it would be
negative
negative 2, and then plus 3 is
Positive 1.
My bad. So it would be positive 1.
So just move the transformation, don't do a t-chart, because a lot of people will get confused with t-chart, just move accordingly, that parent graph, as I quoted it, and move accordingly.
Okay.
So, just go with anchor point style, and
Just
then
take
go
the turning
with,
points.
Yeah, I know. I'm just trying to remember the turning points. So the original graph, we have, this is the anchor point right here, the origin. And then we also have 1, 1 as another point. So we can transform this point, not this then. We can transform this point, 1, 1, using this formula. So we know we need to move it what? We need to move it to the right 6. So that's gonna be 1, 2, 3, 4, 5, 6. It's gonna be right here.
You're up there.
And then we move it up 3. 1, 2, 3.
But then it's
I'm
negative.
doing this wrong. This is negative.
Yeah.
so when they flip
Because
accordingly.
remember, yeah.
So I'm gonna help her with the first one.
Because remember, this is
So you're moving 6 unit to the right, right? And then you go up 3,
Yes.
and then
Negative, so,
this one is inverted, so it's going this way.
so the point would still stay there.
Yes, still, that, so what I point like the inverted is inverted toward x direction. Okay, if the negative sign is inverted x direction, but using anchor point is it's not reflecting across x-axis, it's referring based on the anchor point, so it's gonna flip over. Usually that's gonna be a 1, 1, but it's gonna flip over, it's gonna be 1, negative 1. But based on that point, based on the anchor point, treat that anchor point as 0, 0.
my bad. You basically just reflect it over because it's negative. So let's just have another turning point, which is 4, 2. So 4, 1, 2. So right here. So we're gonna move it to the right 6 times.
So based on the anchor point, move right 4 down 2 instead.
Right 4 down 2.
Yeah.
Okay.
Based on
one.
the anchor point.
Oh yeah, based on the anchor point. So you have the
right 4.
1, 2, 3, 4 down 2, 1, 2.
There we go.
You get the same thing if you just did the transformation with this point. What he's doing right now is he's taking the anchor point and he's going to move like how it is in the other graph. Does that make sense? Does anyone have questions? Ask questions if you have questions. Yeah.
Okay, so you got the anchor point, you moved it to the right 6 and then up 3.
Mhm.
And then, so why do the points go that way? Because in first,
It's going this way
Like
because
it-
it's negative.
oh, okay.
If it was positive, it's going this way. But right now it's going negative, so it's going this way.
Okay.
I know, I'm doing really fast. 1 second. Okay, so now that we have our points, our turning points, we can just use the graph. So it should look like this. But this circle is going to change because we have the restriction of this, and that's an open circle. So we're just gonna put an open circle there.
Why is it negative?
Why is it negative?
Yeah, like why is it going that way, not the other way?
Because there's a negative in front of the entire graph, like the entire equation.
So what would be the difference if it was positive?
So let's just say we had y equals I don't know, x. But if we did negative, that graph would be flipped, right? That's essentially what we're doing. We're taking the graph and instead like a positive slope will be like this. But a negative slope instead would be going in the inverse. Does that make sense? Yeah? No? Yes? Okay, here, let's do this. So we have a normal graph. I'm putting this as an example to show her what happens when you have a negative in front of the equation. So we have a y-intercept of 2, 1, 2, y negative 2, because y equals to x minus 3. So you're going to have this and your slope goes this way. Does that make sense? Wow, how I got that graph? However, if you had a negative slope, it would be going a different way. So let's just say I plugged in -1 for x. I plugged in -1 for x, you get +1 plus 2, that would just be 3. So that would be -1, +3. So -1, wait, -1, 1, 2,
Why'd you go
3.
down 2?
What?
Why did you go down 2?
Because I'm not thinking. And your y-intercept will be the same. Basically what I'm trying to say is that it flips the graph.
Yeah, I got it.
Does that make sense? Okay.
Thank you.
And then jump in.
Yeah, you can go ahead. Do the next one.
Very good. Real quick, did you understand what she was trying to tell you? Yeah? Okay. So, does everybody actually get this whole part right here?
Yeah.
I see, no? Okay. So, alright. If we go to 0, 0, right? So, we know parent function, like she said. Over here, y equals square root of x, that's the parent function. If we were to graph that over here, anchor point is at 0, 0, right? So far, so good. So if we were to go ahead and plug in 1, right, it'd be 1, 1. And then if we go 4, 1, 2, 3, 4, and then plug that in there, the square root of 4 is 2. So we would go up 2. So 4, 2, boom. And then our graph would look something like that, right? That's the parent function. Basically, all we're doing is applying these transformations to this. Yeah, that's all we're doing. It's literally just what we were doing before, but now with more complex kind of graphs, right? So it's the same deal whenever you can think of this, right, inside the radical, it's a parentheses. So whenever you have this inside the parentheses, it's gonna be the opposite, right? That's why we did move it to the right, because it's -6. Inside the parentheses means that we're gonna move it to the right, 1, 2, 3, 4, 5, 6, right? And then over here, what's on the outside is gonna apply to the y. So we move it up 3, so 1, 2, 3. And that would be the first point on this graph, right? So far, so good? Okay. And then, basically, right, whenever you have the negative in front of it, if, let's say, we wanna make our parent function this instead, with the negative, then we're still gonna start at 0, 0, right? So the starting point isn't gonna change. But then if we were to put 2 in there, or no, sorry, not 2, if we were to put 1 in there, right? Exactly, it would be -1. And -1 is right here, right? And then if we were to put a 4 in there, then it'd be -2, right? So -2, 1, 2, 3, 4, boom, -2. See, so this is a little bit closer to that since it does have a negative sign in front of it. So this is what we are transforming, right? So we're gonna bring all these points, apply this transformation. So we're gonna go right 6, so 1, 2, 3, 4, 5, 6, and then up 3, so 1, 2, 3. And that's our second point, right? And then third point over here, we can do the same thing, so go over 6, and then up 3, and then boom, that's your third point. And then that would be your first graph. And then apply restriction. It says that x is greater than 6, not greater than or equal to. So we look for 6, right? X equals 6 is right here. So we go up to meet the graph, and then boom, open circle. That's our first graph. Everybody good so far?
Yes.
All right, good. All right, now over here, let's go and erase this so that there's not so much stuff. All right. Parent function of this graph would be this, right? So y equals absolute value of x. So if we start at 0, right? Absolute, so if x equals 0, then y is gonna equal 0 because the absolute value is 0 is 0, right? So that'd be our anchor point. And so again, if we want to make it closer to what we have over here, we're gonna go ahead and put a negative sign in front of it. So let's say we have 1, it's gonna be a -1, right? So we go x equals 1, absolute value of 1 is 1, correct? So then now it becomes negative since there is a negative sign in front, so it's gonna be there. 2, same deal, it's gonna be 2, so it's gonna move down here. Over here, if we have -1, it'll become +1, but then it'll become negative again because we do have the negative sign in front, so it'd be there. And then so on and so forth, and the graph would start to look like this, right?
Look like a B. Look like a B.
Yeah, exactly, it looks like a V. Because remember, that's the one that looks like a V. Parabolas, y equals x squared, looks like a U. Just remember that those two are different. All right, now, yep, exactly. Huh?
On that side, cause you're blocking it.
Oh, my bad. All right, so yeah, so now we're gonna go ahead and apply the transformation, right? So same deal, you can treat this like there's a parentheses right there. So we will be moving like the opposite. So that's a -4, so whatever you're gonna move.
Right 4.
Right, 4, exactly. So we're gonna take this anchor point first, right? We're gonna move 1, 2, 3, 4, and then we're moving up or down 2. Up, good job. So we're gonna go 4, and then up 2, and that's gonna be our anchor point, right? So same thing, we're gonna take like significant points that we actually have on there and apply the transformation. So we're gonna go over 4, so 1, 2, 3, 4, and then up 2, that'll be your next. And then, honestly, you don't need to do every single point. If you know what the graph looks like already, and you know how, like, if you go over 2 and you go down 2, that's gonna be your next point. You can do the same thing, because, right, this is the anchor point. So you can just go over 2 and then down 2. That'd be your next point. And then we're not gonna go any further, because that would fail a vertical line test. So there'd be no point. No pun intended. And then we can go over here. It goes over 1, down 1, over 2, down 2. Again, because if we were to go over here, it's over 2, down 2. It's just stuff that you might want to, just memorize so you can know. So our graph starts to look like this. I draw that line right there. Draw that line there. Let's go ahead and look at the restrictions so we see exactly how far we need to go. So over here it says x is greater than 1. So x is greater than 1. So x1 right there. So we're going to go over 1 more. So we're going to go there. I'm going to erase this parent function real quick. So we're going to go there, and then it's greater than 1, so it's going to be an open circle, right? Boom, connect that. And then over here, x is less than or equal to 4. So we're going to remove that arrow, but we're just going to leave that as a closed circle. And that would be our second one, right? Is anybody lost? Please nod if you're lost.
Like raise your hand if you're completely lost.
Yeah.
Or
Question?
You put it goes all the way to 6 where the absolute
Yeah.
value graph.
That's what I was about.
Does it? Oh,
Yeah, because the exception is.
my bad. Alright, thank you for catching that. Yeah, so there you go. Not do the second thing, thank you. Anything else
I
besides
think
that?
you wrote the graph wrong. It
Yeah,
should
'cause
be
you put
4, it should be
4.
6. On the
Huh?
You wanna change it to 6?
Because you originally had it as a.
Oh, 6, yeah,
Yeah,
change
okay.
it to 6.
Aha. Alright. So now, we're gonna go to 6, boom. We're back to square one. Alright, does anybody actually have like any questions, comments, concerns, anything that you're confused about?
Did
Yeah.
you do anything with the x minus 4 since it's the absolute value?
Well, okay, so,
Or did it just, you still need to write for it?
yeah, exactly, yeah, cause like I said, you can treat like parentheses, right? You just don't wanna write it like that whenever you're trying to do this, because it just looks a lot more confusing. But you can remember that right here, there is a set of parentheses. So if there is like a -4, then you're gonna move to the right 4, right? And if there's a +2 inside of here, you're gonna move to the left 2. Right? Cause there is kind of a set of parentheses inside there. Anything else? Good? Great. Alright. Now the next one. So we have x plus 1 squared minus 1. And that's the restriction. So we're gonna do the same thing, right? We're gonna start with the parent function. So, okay. So there's no negative. So this time, our parent function is just gonna be this. Nice and clear. Yeah, it's a parabola. Because if you look, see, this thing is being squared. So that's how you can just kind of tell. And like I said, this stuff is that's just transformations. There's nothing too complicated. It's literally just what we've been doing. So we can start with the parent function over here, right? Anchor point / vertex 0, 0. And then if x equals 1, then 1 squared is 1, right? 2 squared is 4. I think we all agree on that. And then over here, -1 squared is +1. -2 squared is +4. So then our parent function starts to look like this, right? So now, once again, we're gonna go ahead and apply transformations. So inside here, if you look, there's a +1 inside the parentheses. So where are we gonna move? Left 1, good job. So over here, we're gonna move that, left 1. And then we have a -1 on the outside, which means we're gonna move down 1. So left 1 and then down 1. That's gonna become our new vertex, right? And then over here, we're gonna move left 1, down 1, left 1, down 1. So let me go ahead and erase this. Boom. And then over 2, 1, 2, 3, 4. Your next one. And then same thing over here. And that's what our graph starts to look like. So now let's go and look at restriction. Over here it says x is less than 1, not less than or equal to. So we're gonna go over here, that is indeed x is 1. So we're gonna put an open circle there. We'll start to connect these. But before I continue, let me look over here again. It says x is greater than -2. So we're gonna go find x -2. Looks like it's right there. So we're gonna go ahead and put an open circle since it is not equal to. And boom. That's our third one. And nothing fails vertical line test, so I think we're good. And everybody good? Yeah? Cool. So now let's move to the last one. So this one, I don't know if you remember, this is the one that we got the gang sign for. This is the one with the asymptotes, the 1 over x. Right? Gang sign? Yeah. Right hand goes in front and then left hand behind. Yeah, right hand points up. There you go.
This?
Yeah, exactly. Huh?
Why you know this?
Because I saw Mr. Lee do it. Yeah, so.
It's the first quadrant and third
Yeah.
quadrant.
Exactly. There we go. That's the other side. Alright, anyway. So in this case, if you look closely, you'll see that there is indeed a negative. So that's what a parent function is gonna look like, right?
So it's gonna put
Exactly. So everything instead of being like that and that, we're gonna kind of flip everything across the x-axis, right? Because whenever you have a negative in front of like a linear equation or any equation for a line, what it does is that it makes everything basically reflect across the x-axis. That's what happens when you flip negative. So instead of being here and here, we're gonna flip it, so it's gonna become like this and this, right? So let's go ahead and look at the transformation. Again, down here, right by the x being added to it, we can pretend like there's a little set of parentheses right down there. So that is a 5, it's gonna be to the left, right? Because it's plus 5, so we're moving to the left. So over here, that is our anchor point. We're gonna move 1, 2, 3, 4, 5 to the left. That is our new anchor point, right? And then up 1. So actually that's not. This right here is. Alright, and now it is the 1 over x. We are going to have our asymptotes, right? So we're going to have this one here, and then this one over here.
No.
Nope, you're right. I went down too much. There we go. So those are our 2 asymptotes, right? So now we can start graphing our stuff. So if we were to plug in 1 to our parent function, right, it'd be negative 1, because 1 over 1 is 1. So over here, we can go ahead and pretend, because we can pretend like this right here is 0, 0, right? Since we are just like moving it around, we can treat it this, the anchor point, like is 0. That's why it's called the anchor point. It's like everything in relation to it is the same, no matter where the anchor point is, right? So the anchor point could be here, and it would be like the point, okay, so if we have the anchor point down here, right? And there's a point right here, if we move the anchor point up here, the point would still be there, right? So everything in relation to it is the same. So we're gonna treat that like it's 0, 0. And if we have a 1 as x, then it's gonna be negative 1. So our first point is gonna be here. And then if we say we want like negative 1, then we can go, that's 2 negatives, so it's gonna be a positive, so exactly, so it's gonna be, boom, right here.
And that's good enough for all the points, and now just generalize everything.
Just generalize, alright. So yeah, so we know that it's gonna go like something like this, right? Boom. I don't know, maybe more. And then this one right here is gonna go like something like this, right? Again, game sign. And then let's go ahead and look at our restriction. It's x is less than negative 2. So we're gonna go ahead and look for where x is negative 2 right there. We're gonna put like an open circle, not quite on the line, but close enough so that it looks convincing. So boom. There you go.
Any questions?
How'd you get the second point on that side?
What, this?
Yeah, how'd you get that?
Oh, okay, so if you remember, right, I'm just gonna make like a little makeshift graph over here. So if you remember, the regular just like 1 over x, right? The way that that looks, it looks kind of like this and this. And remember the reason for that is because like we have, if we have 4, for example, right, x equals 4, so we go like all the way to 4, then y would be 1/4. So then it goes like exponentially, you know, closer and closer and closer. So that's, we can, basically we just generalized, right? And then we can go and add some arrows if you wanted. There, and there. Because those keep on going, like forever. So yeah, so that's how I found that.
Good job, Benjamin. So I have a couple questions posted up there, and I want you guys to try it. And Benjamin, Anam, and Josephine is gonna go around and help out. And if you can help out, go ahead and help out. And then thank you for Josephine and Benjamin.
This is mainly Benjamin.
I know, well, you did good, you tried.
But
You
no,
tried.
it's
okay.
no, I think it's a learning process for everybody. I think for me it's also a learning process as well. Like for now watching other people, I tended to say, oh, and like a lot of things I just come in intuitively, and it just makes sense for me. But I realize it doesn't make sense to the rest of the students. So a lot of times I think he pointed out something really good is make sure you have a parenthesis over there, which is that I never do. So that's something that, you know, a lot of people have advantage of what I explain thing. And I always enjoy what Benjamin teach too, and the same as Josephine. They have 2 different styles. One is very like a motherly. I think.
When I say what I say.
And the other one is patient, and just kind of go through, even is a little bit misunderstanding, you go through it. So which is really good on either one, because But her speed is a little bit faster. So there are things like that, so we can all improve. You remind me of this professor in MIT. And who talk really fast. I'm gonna show you a video of her. But yeah, so let's try turn on the light and try the problem. And there's a problem in the back. I want you to tell me the equation also. So, and just a time test today. So see what happened. Your homework's like based on this. Those two over there.
Are you gonna use this?
Oh, no. Yeah, you can use it.
Yeah, you should do it first because other people haven't started yet. And that professor looked like you, Joseph.
What I say?
What happened if they give us a graph after, what happened if they give us a graph after the transformation we did, and they're asking us for the original graph? How would you do that?
Oh, well, that's actually a lot easier than you think. So if you were looking for like the, what do you call it, the parent function of like, you know this looks like a parabola, right? You know that it functions like a parabola, then literally, the parent function of that is literally just like y equals x squared.
No, I'm talking about like, you're asking what transformation you did
Oh,
to achieve that.
Oh, you didn't do the Benjamin.
Yeah.
It's okay.
It's okay?
Graph first.
Okay, I think it's pretty self.
Yeah,
Yeah, it's like the same.
It's like if you know how to do a last test.
And so once you get to that, you go.
So this means that you can then you should be on the
So,
Just do it.
thank you though. So your original graph.
I can have Sandy.
No, you already got it. I'm giving
So
her.
what he's doing.
I got a last word all
Then
the
let's
way.
just say we had a graph like this.
I have to say, like, my class, something, I'm not saying like I'm a good teacher, but I have a great students. Because my student can teach better than all the teachers. That's why I can guarantee that.
I know for sure this student.
I know for sure my student can teach better than all the students, all the teachers. So, you know, actually they should fire all of them and hire all you guys, because you guys will do such a wonderful job. Like, honestly,
So -1 over.
like you should see some of the teacher out there right now. It's
And
horrendous.
thank God I have never had like a bad math teacher.
Really?
Who did you do last year?
Last year I used to try to prove it.
Oh, lucky you right now.
So this will be the parent function, but I'm gonna add
What I'm missing is that they
Right now, I know what my problem is. My problem is I didn't eat, and also I didn't drink.
My sister.
So I'm gonna, I lost time and do also but after that,
in
it's
this
still a
case,
headache.
here, because ankle point is saying,
Thank you, Dora.
ankle point is saying the area that this thing revolves around. So, here, let me show you on the board.
Would you like a miniature?
So the anchor point for the thing is usually here. The anchor point for the.
And like there are more options. You
What
don't
do you call it? What do you call it?
Okay, I will.
Why don't you do that? Okay, because the restriction. See, it says that x has to be less than -2. That means that x cannot be any of the values over here. Because if it was any of the values over here, it would break the vertical line.
So this isn't on the line.
It isn't on the line, or it's on the asymptotes, because it can never touch that.
So it isn't.
It isn't, he just, that's why he's like, okay.
So this isn't like exactly how it's supposed to be.
This is how it should generally look. I don't think Mr. Ray is gonna be like, oh, you need to find like 1 over -16 or something like that, you know? He was just like, as long as you have the structure of the graph and you know where the turning points are, you know where the anchor point is and where the asymptote is. Like this graph is kind of
What if you move up? Because the thing is here.
because plus 1.
Parent function. So that one is
Now, every time you graph, please check your decimals and check if your graph's right. That's how you get master at this, because if you don't check it, there's no point doing homework. Yeah, absolutely no point doing homework unless you check it.
Yeah.
You can continue. Are you still teaching?
that was good.
I just thought the equation, right, it looks like that. Wait, but question, is that open and is that open?
Yeah, those are, that's open and that's open.
Yeah, well, let's see these. We have what?
Okay.
Square root
Oh, the cube.
x
The cube graph.
2.
Is that the MIT teacher who you claim sounded like Josephine?
Yeah, that, look,
Okay.
look, look, look.
She wasn't that fast, but yeah.
No, you just see the comment on the bottom. Just
What?
see the comment.
What are the comments?
You have to scroll down.
What are the comments? Oh wait, is it still recording? Wait, it's still recording?
Look, look.
Didn't write down this in the book, so I don't know.
Oh, okay. So with this, right, if you want, you can just kind of figure it out every time. Like, you can
And she talked about is that.
That's me.
you want to plug in things that you know are perfect square roots, so you can create it easily. So like, for example, 1, square root of 1 is 1, right? Because 1 times 1 equals 1.
Remember that it was like.
Exactly, so that'd be the first point. Well, no, the origin is first, right? That's what you then be your input point. And then over at
Okay, you said the
2,
green jar?
when, 4, if we plug in 4 for x, if we plug in 2 for x, we're gonna get like the graph for 2, you know,
And you say
but we can plug in 4 since it's, you know, perfect square root. And then
No, I said
4
you guys get this a little bit. Like, you understand what I mean?
And then if we really wanted to, we can go all the way to
Sounds like
9.
Joseph.
Oh my god.
If we plug that in, then that would give us 3, right? So that would give us a point. And then you can just draw a little line through there. Boom, that's what that looks like.
Sounds exactly like
Exactly.
It's literally just, literally just, you're gonna look like that.
Is that your mom?
Oh my god, no.
Is that your toy?
No. Not that I know.
For this, remember, you don't need to worry about it. You don't need to worry about what
She writes like her too.
Right? So for example, for this, if we plug in 2.
Just so that you go for out the teaching
You know exactly what it is.
Not gonna go MIT,
So,
go teach
what
you.
we're going to do is like 1, because 1 times 4, right? So that's a perfect square root. Just plug in the perfect square root. So like,
And she'll be like, any question, and nobody see you.
Yeah, no one says anything.
And then she keeps talking, trying to catch up or trying to solve.
worry about this later, right? This comes second.
No one says anything. I'm like,
Do you have anything in graphic?
I'm sorry.
So over here.
No, you have a good part.
I definitely teach like, I think it's
So
just
what I mean.
Yeah, that is, it's not
when
everybody.
it's person to person, it's
Right,
like,
like the base, the bare bones.
when it's just
is
one,
gonna be wide.
I mean, like yesterday I was teaching Greek physics,
So
I think it's like.
what I mean is that first graph this, and then apply like move, private to right, and then move up to. Yeah, okay, so like, you know, the other origin.
That's where you want to start it, right?
Exactly, so yes, so start with this guy, so over here, we would want to. Yeah, exactly, so first we're gonna do, that's what we're gonna do. We're gonna do 1 for x, that's where we want to. So 1 equals to 0. And then another we use for.
You can grab it, you cannot just write it, you have to grab it. Why you avoid grabbing?
2.
Your test is gonna be based on graphing, not based on where you write it down.
Oh, so the one we plug in is gonna be, go
It's gonna be
to the right, and then like.
yeah. So first we're gonna graph the bare.
It is entirely graphic.
Once we're done graphing this, then we can do this one, right? We can go 1, 2, 3, 4, 5, and then up to 1, 2. So that would be our new paper. So then we can erase that, and then we can apply it to this. Exactly. So once you memorize,
if you have a problem.
you know the first one's here, second one's here. Maybe just 1 second. So you know third one's here. Then you can treat this point as 0.
Yeah, so it would be 100 and 1, 2, 3, 4, 1, 2, right there.
Exactly. So then boom, that'll be your first graph.
Okay, so
Then we'll
here,
first graph.
Yeah,
So here it'll be 1, 2, 3, 4, 5. So
because X is,
remember.
so our equation is y is
So boom, that'll be your first graph.
x. So plug in -3. -3, what's the absolute value of negative?
Yeah, let's do the.
What's the absolute value
That'll
of
be your
negative?
first graph.
oh, okay.
One,
You get it now?
Yeah, I got it.
If you want to
0,
continue.
0, 1, 1,
No problem.
2, 2, 3, 3. Okay?
Is there yet? Is
So
there?
let's just start with
Graph.
we're gonna have yeah, the same thing over here.
Bro, I got Toy Story themed, goldfish. That is awesome.
Yeah, it's not making. There we go.
Where?
Do you understand?
Is anybody-
That's pretty much
Wait,
it.
can you just confirm if I wrote my thing correctly?
Yeah, we put the transformation. So in this case, what would happen?
X minus 7 cubed plus 2, x is greater than 5. Negative
Four
x
and
minus
same with
1
y.
squared minus 1.
So let's just say,
Negative x
let's
minus
just say
1
we have
squared
this,
minus
but
1.
instead now we have a negative.
1
That will cause this to be.
And then the restriction.
We had a negative in front.
Or, okay, so for the second one, that's greater than or equal. So that's greater than.
Wait, 1 greater than equal to?
So one less than or equal to.
Yeah, 1 is less than equal to x. Negative 3 is.
So you basically just flip it over the x, and then you can do
Yes.
And it'll be.
Graphing.
Yep.
Less than or equal.
Waste a lot of those.
No, it's right.
Anyone know what's goldfish?
It's already been over.
Oh yeah, I just opened it.
By the time you finish, the class is real.
I will plug in 1.
Yes.
And then it will be
X has to be greater than 5.
0,
1, 2,
right?
3, 4, 5.
0, but then there's a minus
So,
4.
okay, real quick, what's the pill?
Yeah, so it's just everything.
Yeah, exactly. So graph this.
Yeah, this is what we right there.
Now, plug in the next one.
Which is, plug in 1. Yeah, 1, but then it would be 0, right?
Okay.
This is 0, but.
So whenever I say plug in one, I don't mean plug into this one, plug in this.
Oh.
Why do you have it past this?
And now over here, you have to make sure that if it does have a negative in front of it, put the negative in front of it,
So,
right?
there's the original paragraph, okay, so.
Otherwise-
Right here, then plug in 1.
Yeah.
Instead, like I said,
So
you need a
we're going
negative.
to
So
use the
if
origin,
absolute value,
or the finger point.
so
1,
you
2, 3, 4,
Y.
5, 6, 7.
this is what you wrote down,
Okay, up to
but I want you to add a
Yeah.
negative, right?
Same thing
Because
with
this
the
one
ice.
has a negative.
Okay, and now you're gonna do 1,
So
2,
if you do that,
Yeah. So, oh, so then it's negative now, so we down here.
so if we plug in positive one, we plug in.
Oh, we have a positive 1 and then.
No, we plug in, and so
So if you plug in 5
absolute
for
value is
this,
positive one, is
5
fine.
minus 7 is
But
negative
then
2,
we're
that'd be 8,
multiplying it by the
which is
negative.
10.
So then it becomes one, negative one.
5 minus 7, negative 2.
Okay, so the one we plug in,
Negative
the one that we
negative 6.
left or right, and then the one that, the result is gonna be up and down.
Yeah. So over here,
I'm not done.
if we plug in, let's say,
I don't think we
negative
should
one,
intersect.
right? So
Wait,
absolute
that's
value.
down
No, no, it's
Yeah.
down there. I just made it.
So over here, if we
Yeah,
plug in
because you-
negative one
So
for
it would
x,
be, negative 1 still.
exactly, so
That's
it's
fine.
negative one.
Okay,
Remember,
your
whenever
graph
we're going for
is
x,
wrong, you probably wanna plug in 5 into the equation. So you can figure out like the difference. So like replace x with 5.
Well, I got it.
Take a picture of the back, you gotta figure out the equation of that.
That one.
No, you have other homework.
Yeah.
This is just an example of what a
So
homework.
then, this is like the graph.
Then that one more time, we would make this, right? So x has to be negative 1, that should be from,
So here, so before we do that, so now this graph is my information. So we can go.
I feel better.
You don't think this like her? It's just like, this is how she teaches.
Yeah, like the hand movement.
Yeah, the hand movement.
Wait, Mr. Mayor, you're gonna have to tutor your school today?
If I'm alive,
Yeah, if you're
I
alive.
feel like I'm not gonna be alive.
So we apply,
Okay,
so first we got this, then we apply
Yes, A or
negative
no?
1.
What about and?
That's the 5, it has to be So we want you to reach the 5. You need to reach the 5.
So,
Wait, what room is A?
What are you supposed to, I don't know what to do.
we're gonna take the
Those bins out.